Awesome. Now, today, like I said, it's our day 8. We're going to walk through the wish list smart contract that we developed in our previous sessions. And just to give us some heads up, if you don't have a project idea yet, please brainstorm, come up with one, and start working on them as soon as possible. And what we're going to need for this session is basically what we installed in a previous session. So basically the tools you need, the Rust tools and the near CLI, the testnet account. And this particular tool is going to help us compile our smart contract to WebAssembly. So we're only going to walk through our wishlist smart contract code today. So not really much. And yeah, let's get this going. Now, yeah, so we are here. Now, I just want us to sort of go through what we did in our previous session. That is the smart contract I developed for this particular wish list on a barebone Rust program, right? So here it is. Here it is. So I think we're going to start. Let's start. Okay, let's start here with the vehicle file. That is vehicle.rs file. So this is basically how you're going to defining the object or a structure that our vehicle object is going to take. So in this case, our vehicle had the name, model, mileage, year, and price. And we were using this new function to sort of bootstrap our object. So give it all these components. Then in our user.rs file, here we also had another structure, the user structure. And we also gave it some instances right here. So we used email and vehicle. So email was basically used to uniquely identify the user because our program was sort of going to, going to have a lot of users. So it was wise for us to store each user's records against their email address. That way we are able to uniquely identify users within our platform. Then the vehicles instance variable was basically going to store a list of vehicles. Now, we had the new function that was simply bootstrapping our user object. Then we had the 3 important functions to our program. So the first function was an add function, which was basically adding a vehicle to our wish list. And we did that by capturing this information as provided by the user. Then using those information, we came up with a vehicle object, or we sort of formed a vehicle object or constructed a vehicle object using them. Then after that, we stored that particular information against the user, that is the user's email, within our database. So we used vehicles.insert method to basically store the information. Now, to retrieve the information and show it back to user, we came up, or we availed this show method in place, which was basically retrieving the information using the user's email address. And it was getting all that. And if the information existed, it was returning some data. If the user did not store any vehicle record within the wish list, then we returned null. Then right here, our remove function was basically removing the user records or the user's record within our database. So it basically removed the user, that is according to the email address from our database. And in our main.rs file, we gave a demo. So here's the email address we were using, kevin@gmail.com. And then right here, we were coming up with a new user object using the email address we just availed up there. Then we were printing the email address on line 14, then line 16, we came up with the model of our vehicle we wanted to add to our database or to our wish list. Then we used the user.add method, as you've seen over here. Yeah, this user.add method, that is basically what we used right here to add, to add this particular information to our database. Okay. So right here. So that is what we use to add this user record to our database. Sorry, right there. Then we were basically in line 19, that is, we were printing or sort of retrieving the car information in the user's wish list. So we were retrieving that information using the show method and displaying it in our terminal. So that is basically how the barebone Rust our wish list our wish list program looked like in our barebone smart Rust program. Now, I'm going to switch to the smart contract. I already worked on this, guys, so we're just going to walk through it. And it's basically what you've seen here. In case you're having any questions, in case you're not going to get anything, please feel free to raise it up. You can just lift up your hand. I'll unmute you, and you'll be able to raise up the concern. Now, for now, let me just share that particular window. Okay. Is it this? So let me just close everything for now. I really hope this is it. Awesome. So I hope you can see my window. Now, if you look at the sidebar of my VS Code, we are having our smart contract project. So that is the folder structure and all the files. And we were working from the source of SRC folder. And you realize we have the same files that I had in my previous project, with an exemption of lib.rs. Now, in the previous project I've just shown us, we had main.rs. That was a binary Rust program or project. In this case, we are writing a Rust smart contract, and near we're able to do that using the Rust, or rather by setting up a Rust library project. So that is what is going to help us compile it down to WebAssembly and be able to deploy it on blockchain. So that's why you realize that we have this lib.rs file in place. So even before we go through what's in the lib.rs file, I want us to first of all, sorry, let me just close that. I want us to first of all begin with our vehicle. So vehicle.rs file. So this is basically the file that we began with in the previous project. And right here, just like the previous project, we came up with the vehicle structure that is going to help us bootstrap a vehicle object while we're going to store the information. So right here, there are a bit of some differences with the previous program I've just shown us, because there's some information I've added on the vehicle object itself, structure itself. And then there are some near blockchain modules that I've also put in place to help us have this run on the near protocol blockchain smoothly. Now, other than what we saw in the previous program, I added the image instance variable, the image property to this particular vehicle structure. Then here, there's a new method that is basically going to help us construct the vehicle object. So basically passing all the information we need to do that right here. And that is how we bootstrap that particular object. Now, for me to be able to serialize this, so serialization is basically when this program is going to run on blockchain, it is going to be serialized to store its state. And when it is going to be re-executed, so that is if you execute it for the second time, or for the preceding times, then it is going to be deserialized. That is from the state that was stored on blockchain. That is basically what is going to be deserialized, and you'll proceed with the state as it was previously. Now, these methods are basically what are going to help us achieve that. The clone macro is basically going to help us to be able to clone this particular structure. We're going to see where that is going to be applicable. Then I use the nearby macro decorator as well for us to be able to compile this down to a WebAssembly binary file. So let's move on to the user.rs file. And right here, this is also similar with the user file I showed us in our barebone Rust program, with just some very few changes right here. So I've talked about all these. So they basically do the same thing as well right here. So here, our user structure is basically having a vehicles instance. And the vehicles instance is taking a vector type that is basically going to store an array of our vehicle objects, okay? Now, the vector type I've used in this case is basically the one we saw in during our introduction to Rust programming, okay? So this one is pulled from Rust primitives. So I really hope you can you'll be able to remember that. Then we're implementing a default trait to our user structure and implementing this particular default method. So this is basically going to help us sort of initialize bootstrap our object in case it was not initially initialized. Okay, yeah. And then right here, we have the new user function. Now, this new user function is basically going to help me bootstrap, or rather initialize, a user object from my end, that is. So this one is in place just in case anything unexpected happens, and the program is likely to run without being initialized. So this will help us handle that. But if I wanted to explicitly do it within my program, then I'm going to use this particular function to help me achieve that functionality. And you realize down here, we still have our three functions, very critical to our program: the add, the show, and the remove functions. Now I'll begin with the add function. Now in our add function, just hide that a bit. Add function is basically taking the arguments we need to come up with or to create a vehicle object as passed in by the user. So that is basically what you are capturing as parameters. Then we are right here in line 31, we're coming up with a vehicle object. Then we're basically storing this vehicle object or adding it to a list of vehicles within our array or within our list, okay? Like I said, the vehicle instance variable is a global array. So by pushing it, it will simply append it to the list of other vehicles you already have in our array. Then moving on to the show method. The show method is basically going to help us display what we have within our list. So if you added 1, 2, or whatever number of vehicle objects within your list, the show method is basically going to help us retrieve that. And you realize there's a very long statement right here that is sort of going to help us achieve that. So right here, maybe if I can just reduce the font a bit for you to be able to see that well. So we have self.vehicles. So this is basically the instance variable. We're talking about the global array. Then we are having the iter, or invoking the iter method to sort of make it iterable. Then the skip method is basically going to skip to the index address from which we want to start retrieving our record. So this is basically going to help us paginate our requests. Because assume you had like 100, or you had like 700 records within your array. So it will really be costly for you to sort of retrieve everything at once. Your gas you may run out of gas before you even retrieve the whole list. So in order for us to be able to make our program sort of efficient, we need to paginate our requests so that we are able to specify from which page we want to start retrieving our records and how many records we need. Okay, so that is basically what the start and limit parameters are doing in this case. So skip will help us skip to the particular index where we want to start retrieving our records, and take will basically take the number of elements we've specified in the limit parameter. Okay, I hope that is clear. The clone method is basically going to clone, so sort of make a copy. Okay, make a copy of this particular data structure and collect the objects, in this case, the vehicle objects that have been retrieved. Yeah, the vehicles of objects that have been retrieved. And that is basically going to return to us a vector of vehicles, and we basically return that as it is. So we return the vector of vehicles, so a growable array of the vehicle objects. Then the remove function right here is basically going to help us remove a vehicle record from our database, or a vehicle object from the list of other vehicle objects we have within our database. And right here, you realize that we first of all are going, maybe if I draw your attention to line 41, you realize that the very first thing we are checking in this case is the length of our array, or the length or the size of objects we have within our array. Okay, so in this case, we first of all are converting, because this method, the len method, is basically checking the length of our array, and it is returning a data type of usize. So we're basically converting that to U64. Okay, so we're basically converting that to U64. Then line 42, we assert, or we confirm, that the size of our array is greater than 0, and the index we are trying to remove from our array is less than the size. So this way we are able to prevent unnecessary errors like index out of bound, or you're trying to delete an element from an empty array. Okay, so that is basically what this statement is going to help us do. Then line 43, we basically remove that particular record based on the index address we've specified. So in this case, we remove from this index address we're going to get from the user. So that is it with our user.rs file. So let's hop into the lib.rs files, or rather our main file now. So this is where this sort of the entry to our smart contract. Okay, the entry file to our smart contract. So we're just going to have a look at all this. So for now, guys, there's tests. So I've also availed some tests to this. Let me just share this link actually with us, so that you can be following along as we proceed. Oh, sorry. What am I doing? So we are here. Now, I've already pushed this to a GitHub repo, so you should be able to follow along. You can just go and clone it. That is the link. Awesome. Now, let's first ignore the tests for now and just talk about the main program and what is happening. Then right here, I'm also going to sort of minimize these other functions so that we sort of have a look at the interface of the whole program first, and what's really going on behind the scenes. So right here, we realize that we'll minimize the methods are very few. I'm basically having a method within my contract that is going to add a car record, that is going to read the wish list record of that particular user, that is going to delete a car record from a wish list. And then I have these other private methods right here. So the main methods we have within our smart contract are the add car, read wish list, and delete car. These other methods are private, and I'm going to explain what they actually do. Okay. Now, I think it's good if I begin with the topic we sort of completed with yesterday in our previous session yesterday. So I'm going to basically talk about storage staking. Then from there, we'll proceed with the other functionality within our smart contract based on our wishlist program. So right from here, all these methods, maybe if I can just indicate these here, all these methods are talking about storage staking. So storage staking, yeah, that is what all these files are going to talk about. And I'll just begin with the settled storage cost. So settled storage cost is basically the method we're going to call to help us implement the functionality of a user paying for whatever data they're going to store within our smart contract. Okay, so that we really don't run out of funds within our account or the wallet address where we deploy these particular smart contracts. Now, the very first thing we're doing within this function, that is line 115, is getting the current storage. So the current storage used, or the capacity of storage occupied within our smart contract, that is what we get at that from in that line. Then in line 116, we are getting the used storage. Okay, so the amount of storage that has been added after adding some data to the database. So that is basically what you're trying to capture in line 116. And we are achieving this by, first of all, using the current storage value we retrieved in line 115 and subtracting the initial storage value that we are going to get as a parameter, this function. Then in line 117, we're basically getting the storage byte cost, or the unit price per byte in the near blockchain. And this method is what is going to help us achieve that. Then let's come to line 119, where we basically multiply. So in this case, we basically taking the storage price, so the unit price per byte, multiplied by the storage used for us to be able to get a value that we're now going to charge the user. Okay. So that is basically what you're doing here. I'm using checked multiplication method of this particular data type to help us achieve that. So this is going to return with the payable storage cost. Okay. Here is a payable storage cost. So this is returning an optional enum, enum or object that is basically going to help us retrieve something if actually something was returned, or if there was an error, it will basically return none. Okay, so if something was returned, that is what we are capturing as payable storage cost. And inside this function, so guys, let me also just maybe if you can do away with that first. I want you to have a look at this wall. Yes, so I hope this is visible. So this is what is going to help us do the multiplication, or how we do the multiplication. So storage unit price is of type U128, and used storage is of type U64. So by doing storage unit price dot check multiplication, this method basically requires a data type of U128, but then our used storage is of type U64. So in order for us to do the conversion, we simply invoke the into method for us to be able to easily convert that to the right data type. Then if a payable storage cost was successfully returned to us, then the very first thing we're going to check, that is in the line 120, is if the attached deposit, in this case, the amount of near tokens that the user attached while invoking this function in our smart contract is greater than or equal to whatever they are supposed to pay. Okay, so it's like you're going to a shop, you have some 100 shillings or naira, then a bread costs 50 shillings. So the very first thing before you guys do the transaction, then the shopkeeper is going to check if your 100 shilling is greater than the cost, greater than or equal to the cost of the bread you want to take. Okay, yeah. So that is what you're doing right here. Then in case there's going to be excess, okay, in case you're going to have paid more than required, then it will be very kind of us to return back to you the surplus or the excess, in this case your change, right? So in order for us to be able to do that, we take the attached deposit and we subtract the payable storage cost for us to get the excess. And then we are passing the excess down to this function, refund excess. Now, let's just have a look at what that function is doing down here. So here's the function, refund excess. Now, refund excess method is basically going to accept the value, the excess value, and the signer, in this case, whoever is signing this particular transaction. Then the very first thing you want to check at this point is if the excess is greater than 0, okay? So if actually you have some change or you expect some change from us, if you don't, we don't do anything. But if you expect some change from us, then in line 143, we're basically going to transfer that change to you. And this function or the statement at line 143 is what is going to help us achieve that. So we use a promise. And again, I said, we're going to talk deeply or much about promises in our coming session. That is on cross-contract calls. So promise.new is basically going to accept the signer's address or wallet address. And we're going to use that to transfer the excess amount back to them. Okay, so I really hope that is clear to us, guys. And yes, that is basically what is going on right there. So if our check multiplication method, or if our multiplication didn't happen correct, then you're basically going to raise an error. So our program will basically panic. Okay. And every transaction that was done before then will be rolled back. I hope I talked about that in our previous class. So that is it about the settled storage cost. I'll move on to the refund storage cost. Okay, now we're going to use this method while removing elements from our database. Okay, now that the user paid for the space that their data occupied within your smart contract, it is also kind of us that when they delete that particular record, whatever they paid for the storage of that record is refunded back to them. Okay, so that is basically what this function in line 121, the refund storage cost, is going to help us achieve. Now, the very first thing we are doing right here, same as the previous method, is we are getting the current storage. So the amount of storage occupied, right? Then in line 131, we're basically getting the amount of storage released. Okay, so after deleting a record, we expect, sorry for that, we expect that some storage space is going to be released, right? So for us to be able to sort of calculate that capacity, we're going to use the initial storage, which is going to come again to us as a parameter. So we expect that this initial storage is going to be greater than the space that is going to be occupied by data after removing the record, all the data. So we basically take the initial storage minus the current storage to get the storage released. Then after that, we get the storage unit price. So that is the storage cost, the cost of a byte, or the unit price. of a byte. Then in line 134, we're basically going to multiply. So again, in this case, to get the refundable storage cost. Now, how do we do that? We use the storage unit price and we multiply that by the storage released. Okay, so the space released for us to be able to get the refundable storage cost. And if that went well, then we're basically going to refund the excess by passing the excess excess amount, sorry, in this case, our refundable storage cost and the signer's wallet address. And again, I took us through the refund excess function down here, and I really hope we are able to comprehend that. And in case the multiplication had some errors, and basically panic, okay? So this statement will help us achieve that. Awesome. So that is it about, there's also another method right here that we basically are going to see how we're going to use it in our functions up here. So this is basically going to get us the initial storage, okay? So we're going to use this function to sort of get the initial storage or the space occupied before a user either adds or removes data from the database. So it's as simple as this. That is the function. Now that is it about storage staking. I really hope those of us who are in our yesterday's session, those of us who didn't understand the concept of storage staking, I really hope you now at least can be able to comprehend something. Okay. Awesome. Now let me just move on to our main functions now. So right here, our main functions. I'm going to start with the add car function. So the add car function, like I said, is basically going to help us add a car record to our wish list. Awesome. Let's see how this is done. So the very first thing we're going to do is capture the relevant or the information we require the user to provide. So whatever I've just highlighted, we're going to get that from the user. Then I'm going to get the wallet address of whoever is signing this particular transaction. And in this case, I'm using the predecessor account ID. Now, there's a reason why I decided to go with this method, the predecessor account ID. It basically gives us the immediate account address that is performing operations within our smart contract. Assume, and we're going to see this or how this is going to be done in our coming session. Assume that there are two smart contracts involved in a transaction. So in this case, we are having contract A calling contract B. But then the function that triggered the call to contract B was triggered by a user who also signed in with their wallet address. Okay. So in this case, if we were to use signer account ID like we saw in our previous session while talking about near protocol features, then it means we would get the wallet address of the user who began the transaction or who triggered the transaction. And for security purposes, if you do your research on developing on the near protocol blockchain, you're going to see the advantages and disadvantages to that using the signer account ID method to get the wallet address of whoever is signing your transaction. Now, if you use the predecessor account ID, then you're going to get the immediate account or wallet address that is invoking this particular transaction within your smart contract. So if this function was in contract A, then the predecessor account ID would be the wallet address of the user. However, if the user invoked a function in smart contract A and smart contract A called a method in smart contract B, we're going to see how that is going to happen while we talk about cross contract calls. Then using the predecessor account ID would give us the wallet address of smart contract A. And so that way we are able to track whoever actually called this particular function. So I really hope that is clear, guys. If you have any more clarity you need on that, you can just raise it. Now, I'm going to get the attached deposit. That is the amount of near attached while invoking this particular function in our smart contract. And this is how I do it. So I'm basically going to get the deposit. And for my function to accept any deposit attached to this particular transaction, I'll have to explicitly specify that using the payable macro on line 45, as I've just highlighted right there. Then I'm going to use this method I talked about, the initial storage method in our staking, storage staking methods to get the initial storage in our smart contract. So the storage before this user is going to add their car record to the database, okay? Then immediately after I do that, I get access to our wish. Now here is the database that is going to sort of carry all the user records. In our wish list structure, this instance variable or property wish list is of type lookup map data structure, and it is taking a string as a key and a user object as the object that is going to be stored under that particular key. And we basically, right here, we initializing this using a key prefix value, in this case W. And like I said in our previous session, guys, this is basically to help uniquely identify this particular data structure or storage object on blockchain in relation to a smart contract, so that we don't have the computer sort of being confused on what to return to us. So, and it should be short also to save on the storage space. So it should be short. So this wish list is going to help us store user record. So in this case, we're going to store a record against a user's account ID. Okay, so that if I were to sign in to that particular smart contract and someone else, say Kevin or Destiny, were to sign into that same smart contract, our accounts will not collide, or the information I'm storing that particular on the blockchain will not collide with someone else. And they are also not able to retrieve my data without my permission, unless I granted them or sort of showed them from my end, or unless they have access to my wallet address. That is the only way they're going to be able to do this. Awesome. So back to our add car function right here. So like I said, we are retrieving the user object of this particular user currently logged into our smart contract, or whoever is signing this transaction, using the get method and the assigner or the account ID. We are getting the user object or the information, and we are storing it in this user variable. Then from this user object, we are invoking the add function, and we are passing in all the parameters the user availed to us while calling this particular transaction. Then after adding these values, we need to update that state in our database so that we have it persisted. And line 60 helps us achieve that. So we basically do self.wishlist.insert. So we're basically inserting this, and we're inserting it against the user's wallet address. And whatever we're inserting is the user object that we updated right here in line 52. Now after inserting that particular record to our storage, it means that the storage space occupied by that data has increased. And so some tokens from our smart contract account has been staked to cater for that particular storage space. Now we want the user to sort of pay some money for the amount of storage that was occupied by storing these records on blockchain. And how do we do that? We use the settle storage cost method, like that I talked about. And like I said, we are passing in the initial storage. So the storage before they stored or they added data to the database, the one we got up here, and the attached deposit. In this case, the deposit we also retrieved in line. This should be 48. So that is what we passed down here. And the signer's wallet address. So in this case, what we retrieved in line 47. So that should be able to help us settle the storage cost that is occupied by the data the users just added to the database. Now, so in this case, we are retrieving this record from the database. How about the user was just doing this for the first time? It means the record is not yet captured within our database. And so we need to create it, or rather initialize it, create them an object, and store that object on the blockchain. Okay. So if we didn't find if the user is doing this for the first time, then this if statement will fall on the else block. And right here, we are basically initializing a user object using our new user function I talked about. So this is basically going to get us a user object. Then from that user object, we invoke the add method, passing in the parameters that the user has availed, and storing that particular object or persisting it in our database, same as we did in line 60. So we are inserting this user object against the signer's wallet address. Then after doing that, we settle the storage cost as explained up here. So actually, this statement is similar to what we saw up here, except for the line 63. That is where the catch is. Yeah, and that is basically it about the add car functionality, or the add car method of our smart contract. Okay, guys. So that is basically what happens. Now, let's look at the read wish list. So in this case, a user is trying to retrieve records or a record of cars that he or she stored on the blockchain against his or her wallet address or account ID for now. Okay, so we're passing in, or we expect the user to pass in the start and limit parameters. So these are basically going to help us sort of paginate that particular request so that you don't have everything returned at once to the user. That would really be costly. Now, for us to be able to do this, we first of all capture the wallet address or the signer, whoever is signing this particular transaction. And that is how we go about it, line 78. Then after doing that, we want to check if this user has a record existing in the database. And if they have a record existing in the database, then we'll go ahead and retrieve that particular data. However, if they don't have a record in the database, then we're basically going to return an empty array. So line 80 is basically checking if they have a record in the database and retrieving that record if it is found. Then we store it in the user variable. Then inside this if block, we're basically using this user object, we're invoking the show method, inserting the parameters that the user passed, that is the start and the limit parameters. So this is basically going to help us retrieve a list of vehicle objects, and we're storing that particular value in the vehicles variable and returning it back using the optional enum. So like I said, this object is basically going to help us return something if the value exists, and none if nothing exists. Okay, so if in this case, if the user's record was not found within our database, then you're basically going to return an empty. vector or an empty array. Okay, as captured right there. So I really hope that is clear. That is basically what's happening while we read our wish list. Then let's move on to delete car. Also some very few code right here. Now our delete car, we first of all getting the signer's account ID in line 89. Then we get the initial storage. So we need to know the storage, the amount of storage that was occupied before the user removed their data from the database. That is how we go about it in line 90. Then in line 92, we're basically checking if this user has some record within our database. And if they actually have the record within our database, then we get that record immediately. And we're storing that within this user variable. And if we didn't find any record down here, we're basically returning none. So in this case, now, okay, based on what you're going to see in our terminal. So if we actually found a record in the database, then we're basically going to use the user object returned to us. So this is the object that was stored in our database, and we're going to invoke the remove method on that particular object, passing in the ID of the index of the object we want removed from our database. Okay, so that statement helps us do that. So this method is basically going to remove that object, then return to us the removed object. Okay, so the removed object is going to be stored in the removed vehicle variable. Then after removing this particular vehicle record from our wish list, we need to persist this information again on blockchain so that it's able to reflect for our future transactions. Now to do that, we basically need to insert this updated user object back to our database against our wallet address, or the signer's wallet address in this case. Now, after all that has happened, we expect that the storage space occupied is now going to be, there's some storage space released, or it is going to be less than what we initially had. Now, it will really be kind of us that now that the user paid for that storage space, it will only be kind of us if we can refund that particular money or tokens to them when they delete this particular record, right? Yeah, so again, there's some ethics when it comes to blockchain programming, guys. These are some of the things you really need to take key note of so that you don't have your smart contracts stealing from people. Okay. So right here, we are refunding this cost back to them. Okay. So we are invoking our refund storage cost, passing in the initial storage. So in this case, what we captured up here before they removed the record, and the signer's wallet address, in this case, whoever is signing this particular transaction. Then if all that was successful, we basically return back the removed vehicle record or object so that the user is able to see what they actually removed from the database. And that is it about our wish list smart contract program. I really hope we've got something. Okay. Now, from that point, again, I'll be talking about the tests if time allows. But yeah, I'll be talking about them. But let's first see or run this particular program. Now, I already deployed it on blockchain, but we can just redo this so that we make it transparent as possible. Now, I have my scripts in place already. So I have my build script. As you can see it on your screen, this is basically going to help me compile this smart contract down to a WebAssembly binary file or bytecode. Then my deploy smart contract, oh, sorry, my deploy script file is going to help me deploy my smart contract to the blockchain. Now, there are some very little tweaks you guys can see on the screen compared to what the script files I had yesterday. Now, I just decided to make everything a bit cleaner. So I availed a setting.config file for my script file. So my setting.config file is basically going to hold some variables for me. So if you've worked on these other projects, let's talk about the Node projects or JavaScript projects. You usually have the .env file, okay? So my setting.config file is basically going to act as an env file. So I'm going to have all my environment variables right there. And I'm going to import this file to my script file for me to be able to access this information. And that is what is actually happening in my deploy script file. So line 3 basically imports the setting.config file. Then in line 5, I first of all delete the sub account, passing the master account as the beneficiary account. Then line 7 creates the sub account, passing in the master account as our master account, what we basically provided, listed right here. So wishlist dot whatever we're going to pass as the value to our master account over there. Then line 9 is basically going to deploy our smart contract to this particular sub account, passing in the path of our WASM file. That is actually going to be the path. Okay. Then in our call script, I'm going to again import my setting.config file. Then from here, we're going to perform the three, we're going to invoke the 3 public functions we've looked at in our smart contract. Now, let's first of all get started by our build script. So I'll just launch my terminal over there. I really hope you can see that. Then I'm going to run my build script. So build.ash. And that is basically going to build our smart contract. So I'll compile it down to WebAssembly. And let's hope that is going to work. Let's give it some view time. Awesome. So that was done. After building it, we basically want to deploy. So guys, after building it, it generated this wishlist.wasm file. So we're basically going to deploy that to blockchain. And for us to achieve that functionality, we're going to run our deploy script file. And then the magic is going to happen as we wait. So first of all, it's deleting the sub account. Like I said, I already created one. And then it is going to recreate it. And then after creating it, it's going to deploy the bytecode that was generated, and that was just done. So we already have our smart contract on blockchain, and you can feel, you can as well perform these operations you're going to perform in our terminal from your end, as long as you have the near CLI in place. So you should be able to follow along. Now, let's see. This command is basically going to invoke the add car method in our smart contract. Okay. Now, it's a call function or a change function. So in this case, we're going to call, so near call, passing in the account ID or the wallet address where we deployed our smart contract. In this case, the sub account. And like I said, that value is right here. Okay. So that is basically what is happening there. Then we are specifying the name of the method. In this case, we want to invoke, and the parameters. So there's a long list of parameters right here, guys. I really hope you can see this. So the very first parameter is an image, and I just passed in a link, a very long link, sending up to that point. Then we have the name, Toyota, model RAV4, mileage 1,000, I think, year 2022, and price. So those are the parameters that we need. Then we are specifying the wallet address that is going to sign this particular transaction using this account ID parameter, and we are passing in the wallet address that is basically going to cater for that. And then we're going to attach some near tokens that is going to cater for the storage. So in this case, amount 1 near. Okay. So let's just go ahead and run this particular script file and see what's going to happen. So these should be able to add this record to our wish list. Awesome. So nothing was returned, so it means it was successful. So that is basically going to help us add a record to our wish list. Now, we're going to see how we can read a record from our wish list. So we're going to do near call, specifying the wallet address of the account ID where we deployed our smart contract and the function name we're going to call. So in this case, read wish list. And then we're going to pass our parameters. So the start is basically where we're going to start reading. The limit is the number of vehicle objects we want returned. So in this case, we just specified 10 from index 0. And then we specify the account address that is going to sign this particular transaction as yto.testnet. Yes, yeah. Awesome. So let's go ahead and just run this and see what it is going to return to us. So we expect one record to be returned in an array, of course. Awesome. So here is the vehicle object returned to us in this vehicle array or vector, right, guys? So we have the name as that, image, name, Toyota, model, that, mileage, year, and price. So we have all these returned to us, right? Now, I'm going to try, okay? I'm going to try and invoke this add car function, but this time around without attaching any token or any near token to it, okay? So I'm basically going to run it as it is. So we expect it to raise some error because in this case, we've not attached some amount that is going to cater for what? For the storage. Now let's just give this a try. So we really expect this to raise an error. I really hope that is going to be the case. Yeah, and as you can see, there's this error. It's a function called error. So it basically panicked. It panicked at attached deposit greater than or equal to payable storage cost. Okay, so in this case, it panicked, and we don't expect it to have added the record to our wish list. Why? Because we never catered for the storage space. So let's see if that was actually the case, right? So I'll just return that back. Then I'll comment it out. Then let's try and reread again the records from our wish list. So in this case, we expect the record to be 1. So what we had put initially, and not 2. So let's actually see if that is going to be the case. Awesome. So we still just have 1 record in our database, or in our wish list database. Then I'm going to add another one for us to be able to perform the delete operation, so that again we don't leave our database empty. But you can do so as well. This is just for demo purposes, guys. Let's hope that is going to work. So we expect it to add. I'm having some internet issues. Yeah, so that just added that particular record to our database. Now, if I go ahead again and run read wish list, then we should be able to now get 2 records of vehicles within our database. So there we go. So right here, we now have 2 record of vehicle objects. returned to us. Now, we're going to see how we can delete a record by basically calling, invoking the delete car method of our smart contract. So we're going to do a near call, specifying the sub account or the wallet address where I deployed our smart contract. And then we specify the method name, in this case, delete car, and the ID. So we have some parameters right here, and we are passing in the ID of the car we want to delete. Now you realize we only have 2 cars within our array, right? So it means if we are passing an index that is beyond the bound of our array, it shouldn't cause, or our program should be able to handle it without stalling, okay? Now we're basically going to sign this transaction, and I'm going to go with it as it is. I know this is going to work, but it should panic based on this argument we've passed because it's beyond the bound. So I'll just delete that for now, or clear that out. Then let's see what response is going to be returned to us. It should be an error. Awesome. So here is the error. We are told it's a function called error. And right here, the contract panicked at these, or rather it panicked with this message, wishlist empty. So it means, in this case, we passed something that is not, an index that is beyond our, an index that is beyond the size of our list. And if I can just get back here, so delete should be in user file, I think. Yeah, so right here. So in this case, index. So here we are checking if index is less than the size, but then index was greater than the size. So this message was printed out to us. So that is basically what happened. Yeah. So I'll just get back to the command again. And this time around, we're going to specify index 1. So the last object we added to that particular list. So that is what we're basically going to remove. So I'll clear that out. I'll try and expand this again, then call or run that command. Let's see what that is going to give us this time around. It should give us it should give us an object. So right here. So this object was actually removed from the database. Okay. So it removed it and then it returned it to us. So we're able to see what we actually removed from the database. Now, if I run the read wish list again, I should be able to get just one record within that wish list, just one. And there we go. So that is how we go about that. Now, all through my operations or transactions, I have been using YTO.testnet wallet address. And I just want to show us some things that have been happening while we've been invoking all these functions. So I'll just head on to let me just share this browser. I think it's that. Awesome. So right here. So I'm just going to show us what has been happening, or some records that have been captured on blockchain while I was performing all that operation using YTO.testnet wallet address. So in our recent activities, we should be able to have all that listed there. So I'm apparently logged in to my YTO.testnet wallet address. Then we're just going to go right here under the recent activities, and you realize there's a long list of the methods we've invoked and when they were invoked, and some additional information to them. So the very last one we invoked was a read wish list right here. And the status was successful, so it succeeded. And I invoked this method on these smart contracts. So the smart contract that we called was deployed on the wishlist.paulotino.testnet, right? So I'm just going to view this information on Explorer. So Explorer is where as long as you have a receipt ID, account ID, transaction hash, and all that, you can be able to sort of get a list of information based on that particular transaction. on the blockchain. So in our read wish list, I attached 30 gas. So this is the default gas. That is the default gas attached by default when you do any operation, unless you specify. Then out of the 30, only 5 teragas was used. Okay. I didn't attach any near token. And here was the transaction fee. The status means it succeeded. Here the parameters I passed. So I basically passed the start and the limit with the values. Then down here we have the transaction plan, giving us some other information. So at this point, the arguments, the result that was returned, in this case, yeah, here's the record that we got by running that particular transaction. Then down here, we have a receipt showing us, now that we attached 30 teragas, there's some amount of gas that was used, in this case, 5 teragas, right? Then NIA transferred back to us whatever gas remained. So in this case, this value. So this was transferred back to us. So it was transferred back to our account. And that is basically what happened when we ran the read wish list function in our smart contract. Now, we're just going to see what happened when we added a car. So let me just have this. So in this case, we invoke the add car function on our contract, the wish list contract. And let's have this viewed in Explorer as well. So right here, we have a detailed information about the transaction. So the very first thing to note is that it succeeded. We attached 30 teragas by default, and 6 teragas was used to perform this particular operation. And then we attached 1 NIA token to cater for the storage. And this amount of transaction fee was charged. It happened at this time. This is the hash block, the hash of that particular transaction. I think this is the block height. So here are some of the parameters we passed while invoking that function. You can show more if there's more to show. That is, it was a long list of parameters. Then down here, we have a detailed execution plan. Now, again, the parameters that we call the function with. Then right here, you realize we have this amount transferred back to us. So you remember we attached 1 NIA token to cater for the storage, right? But then just a few out of that was used to stake for the storage space. So the rest, and you remember, I hope you remember how we captured this within our program, the rest was refunded or credited back to our account. So that's why you can see the 0.99 something right here transferred back to us. So this comes from the function we just wrote. And I think this is what was used for the storage. So this is the amount that was used for the storage. Then down here, we still have this transferred back to us. So the excess gas that was attached was also transferred or credited back to account. So that is basically an overview of how transactions on the NIA blockchain happens and how you can as well audit the transactions on the NIA protocol blockchain. You use the explorer.testnet.nia.org. In this case, if you're using the testnet network. If you're on a mainnet network, we have a mainnet network right here, which you can easily use for that. So this one is for the mainnet network once your smart contract goes live. Okay, that is for now. Let's go back to the testnet. Yes, so that is it about that, guys. That is it about that. Now we're going to just talk a little bit about the tests. Let's just talk a little bit about the test, and I'll be giving us some. I want to exit from this. Yeah. Awesome. Now we're going to talk about tests, and I think I wrote them somewhere. So I'll just minimize all these functions for now and expand the test module. So in the test, this is how we write the test. So first of all, I'm bringing in everything we have in our super. So whatever we have in our module right here, the same file that is. Then I have this log function that is going to help me log some information on terminal, and these other blockchain related modules. So these are basically going to help us mock a blockchain context while doing our tests. Then the very first thing we need to do right here is to get the context. So in this case, a mocked virtual context, virtual blockchain context. Then we are specifying the current account ID, the signer's account ID, and the predecessor account ID right there. Then we give some public address to our signer's account. We specify the signer account public key. Then right here, we are specifying the attached deposit. So in this case, 1 year, and some other information guys over there. Then at this point, I'm basically getting the parameters. So this is going to help me easily or very quickly come up with the parameters I want to pass to my, as records to my add function, add car function. Then here is our first test, the add to wish list test method. So this is basically going to test if the add to car functionality is working as expected. Now, my get parameter is returning a tuple with all these data structure, sorry, data type. So right here, I first of all get the context, the mocked or virtual blockchain context, and we put that in place. Then I initialize my smart contract by running wishlist default. Then after that, I get my parameters first and store them as tuple in that variable. Then we have some space. Then from my contract, I invoke the add car method, passing in the parameters as I captured them from the get params method. Then after adding a car, I want to test if I can read that value from the database. So in this case, I'll just go ahead and invoke the read wish list from my car, sorry, from my contract object, passing in the start parameter and the limit parameter. So at this point, since I've just added one car object, I expect the length of my vehicle. So in this case, after reading this wish list, an array of vehicle objects is going to be returned to me. So I expect the length or the size of this particular array to be 1. So that is basically what I'm testing in line 208. Then right here, I again get the parameters. So the reason why I'm getting these parameters is basically to help me do some tests with the already stored car object. Okay. So from the car we just stored, I'm accessing the first element. So that is passing in the index using index 0. Then I'm getting the model property of that particular object. So I expect the value returned here to be equal to the value that is going to be in our test params at position 2. So basically our model. Okay, so right here, our model value. So in this case, around 4. So I expect the two to be equal. If we never, or we weren't able to read this from the database, then it means there's an error somewhere, okay? And I basically log that out if an error occurs. Then the next test functions, I just have the two. Apparently, the add to wishlist and remove from wishlist test functions. So the remove from wishlist test functions is basically the same with these up to some points. So like I said, all the test runs parallel to the other. So again, we just have to write avail everything in place up to, yeah, what I've just highlighted. So up to that point, it's similar with what we've just seen above. Then over here, we're getting or reading the wish list. And given the array returned to us, we are checking if the size is 1. So basically what we did up there, because we just added 1 record. And if that is not, if you are unable to read that, then it means there's an error somewhere. Then after adding, so this is where we sort of dive into testing the remove functionality. Okay. So right here, we are deleting the card that we just added initially in line 2 to 3. So we delete it by passing in the index of the ID. So we expect that to be removed. Now, if we try and access this for the second time, so if we read our wish list down here, based on the array that is going to be returned to us, we expect its length to be 0, right? Because we removed the object we initially had in place. So in any case, it should be empty. So that is what we basically trying to check inside there. And if an error was raised, then I'll try and log it in our terminal. So I'll just go ahead and try run this. So we covered this in our introduction to Rust module. So for us to be able to run tests, we just pass in, or we just run this command, cargo test. So let's see what this is going to give us. So we should execute the 2 unit test functions. And yeah, that was done. So we had 2 tests that were running, the add to wish list and the remove from wish list. And both of them passed. So if you see the green OK, it means they passed. And yeah, 2 passed and all that information. So guys, that is basically how we write the test to our smart contract. And I really hope we've got something from all these explanation. Now, is there anyone with any concern, any question based on what we've covered today? Yes, Isaac, maybe you can just raise it.
Oh, okay. So thank you for that. And my question is how safe is it, or is it safe to add links from the internet to your blockchain app?
Okay, yeah, it depends with what data you're trying to store again, or what your smart contract is trying to do. So in our smart contract, I decided to go with the links for us to easily be able to display the images of these records we're storing on the database. However, if you wanted it to be fully decentralized, then you could store those files on a different blockchain, then retrieve them. So in this case, I'm talking of something like IPFS. IPFS, Filecoin, Web3 storage, they are blockchains that are particularly concerned with storage. Okay, so if you didn't want, or if you don't want the content of your file to be interfered with or to be mutable, then you can simply store the content over there. Then they'll provide you with what we call content ID. So that is basically what you can use to access that particular content on that blockchain. So that is what you can store over here in your smart contract, and that would be easy. So it's again depends on what your smart contract is trying to achieve, or what your smart contract is doing. Is that clear, Isaac?
Yeah, that's clear. Thanks.
Awesome. Yes, anybody else? Anybody else want to go? Okay, so it seems today we don't have a lot of questions. I hope you've really got the explanation that you've had. Now, maybe just before we conclude, there's assignment for today, so over the weekend. So the assignment is going to be, you'll be required to sit your simple bank program on a blockchain. In this case, the near protocol blockchain. So you're basically going to translate your program, your simple bank program, into a smart contract that is going to run on the near protocol blockchain, just the way we've done with our Wishlist program. Okay, so I began by showing us what we did on the barebone Rust program, so how we implemented it as a Rust program, then how we migrated it to a smart contract, and we went ahead and deployed and played around with the functions and all that. So that is exactly what I expect you guys to do over the weekend. Okay, so that is related to function one. I'll be sharing the document for the assignment as well in our group. So if you need some more information or further description of what you actually need to do, I'll be sharing a document to help do that. And also in that document, there's going to be a link where you'll submit your details after finishing or after doing the assignments. Okay. Again, let's continue taking the assignments seriously and also work on our demo projects as soon as we feel comfortable to. Up to this point, actually, I expect us to start working on them, on the demo projects, because we already have everything we need to do a simple demo project. It doesn't have to be complicated, guys. Just something that is going to help you get your certificate. It's as simple as what you do in your universities or any other higher learning institution. You want to do a project that you really understand well. In case there's going to be a question on it, you don't fumble or stumble while asked to explain a concept within your project. So that is what you're going to do. And yeah, if there's no other question, let's meet again on Monday. So next week, we'll be talking about cross-contract calls. We'll be talking about front-end to our smart contracts, and we'll be covering fungible tokens. So we have 3 topics to cover, or 3 topics remaining for this particular training. And after that, I expect you guys to be gurus on this field. So thank you guys for coming, and yeah, can see there's a chat. Thank you, Philip. Thank you. So let's meet tomorrow, please. Sorry, let's meet on Monday. Tomorrow is already on the weekend. Let's meet on Monday. Then we'll be able to get